In Australia and New Zealand, the infrastructure is underpinned by stormwater drainage, sewerage systems and water supply services. These core services rely on a durable system. The most durable system in the industry is steel reinforced concrete pipe. Steel reinforced concrete pipe, when designed, manufactured and installed correctly, will last for over 100 years.
The elements that define durable concrete are the water-cement ratio, compaction of the concrete, concrete cover to the steel reinforcement, the curing regime, supervision. Following these criteria, the concrete used for steel reinforced pipe manufacture rates very highly. That is why steel reinforced concrete pipe is so durable and such an asset to the community. The water-cement ratio or water binder ratio has a long-term effect on the durability of concrete pipe. The lower the water-cement ratio, the higher the strength, and ultimately the better the durability. Steel reinforced concrete pipe is designed to have a water-cement ratio of approximately 0.30. This allows compressive strength in the order of 70 MPa to be achieved at 28 days. Mix design and manufacturing processes ensure that the carefully blended high-quality raw materials used in concrete pipes will compact to form a high-density concrete with a minimum of voids. The factory-based manufacturing processes ensure that the concrete is adequately vibrated and ensures a maximum of compaction without segregation of the components. To determine the effectiveness of this, the water absorption test, defined and conducted in accordance with AS/NZS 4058, indicates durability performance and must show results lower than 6%. The protection of steel reinforcement in concrete pipe is dependent on the concrete cover between the steel and the potential corrosive environment surrounding the pipe. The minimum cover for concrete pipe in various conditions is defined in AS/NZS 4058. The depth of cover is achieved by welding dimensioned steel projections, known as nibs, to the reinforcement cage. The nib bears hard against the mould and thus secures the requisite cover and maintains the reinforcement shape and orientation during the manufacture process. The well-compacted concrete, high in cement content, creates a highly alkaline environment to create a protective barrier against corrosion of the reinforcement. Correct curing regimes are important for the durability of all concrete structures. Steel reinforced concrete pipe manufacturers use low-pressure steam curing to create a moist environment. The elevated temperature accelerates the strength development and the moist environment ensures the cement continues to hydrate. This early strength development is critical to the manufacture process as it facilitates early product handling. Controlled curing is inherent to the short and long-term durability of the steel reinforced concrete pipe. Steel reinforced concrete pipes produced by CPAA members are manufactured by quality assured manufacturers. They are made in a controlled environment, in a factory where quality control and continual monitoring of all facets of the processes are the subject of accredited quality assurance systems. At this level of supervision, skilled operatives will detect and record variation at the earliest time. The process continues under extended levels of supervision. After passing the manufacturing process, steel reinforced concrete pipes are subjected to a number of tests for acceptance before the product is released for use by the consumer. This quality ensures the product is durable. Once the pipe is made, it's important for designers, installers and asset managers to consider the long-term durability of the product. Careful pipe selection, installation and monitoring ensure that the steel reinforced concrete pipe maintains its durability over time. The type of pipe selected by the designer, along with the installation type, is dependent on the required hydraulic capacity, the expected dead and live load conditions, and the environment the pipe will be surrounded by. The long-term durability of the pipe is reliant on careful design considerations to ensure it's given every opportunity to perform. A correctly installed pipeline must follow several criteria to be considered satisfactory and ready for service. When the installation does not provide uniform bedding or where the compaction has been excessive, pipes may exhibit cracking, both longitudinal and circumferential. As a rule, they're not a threat to the asset life expectations of the pipe or its structural adequacy. Circumferential cracking can occur during installation due to loading, uneven bedding, or movement from settlement. Longitudinal cracking, however, is due to overloading and requires detailed review to establish the cause to ensure the structural adequacy is not jeopardised. As steel-reinforced concrete pipes are generally buried underground and carry water, the cement continues to hydrate. As a result, many cracks are able to heal themselves due to a phenomenon known as autogenous healing. To ensure your asset remains durable, regular monitoring may be required. This can be done manually or with closed-circuit television cameras. CCTV cameras are used to inspect non-man entry pipelines and give qualitative data to the asset manager to make an informed decision on the state of the pipe. CCTV cameras can help identify misplaced joints, poor connections, exposed reinforcement, incorrect placement and cracking, but it can't measure the width of the crack. However, correct installation procedures ensure that steel-reinforced concrete pipe remains durable.
The CPAA member companies have been producing reinforced concrete pipe since 1910 and will be major players in water conservation during the 21st century.